Good morning, everyone. Today we have a special guest that are actually going to discuss about one of their product called, I guess, Prelude. I'm not sure what the actual name of the product is, but they're probably better than me to explain their own product. The idea here is that I want to show you that there's multiple options. The cool thing about this one is it's actually open source. The product is free on its own. They do actually provide some support, pay support, but they can probably tell you about it a bit more. The cool thing that you'll see is that you can kind of script all kind of stuff inside of the tool, so you can automate part of your red team. So without further ado, I'll pass it along the Prelude team, and I'll let them introduce their tool sets.
Awesome. Thanks a lot. We really appreciate being here tonight. So my name is David Hunt. So I'm the CTO at Prelude, and I'll give you my quick background and pass it to Alex to give his, and then we will just jump right into kind of a tool demo and chat about that. So my background is kind of a mix of public and private sector over the last 16 or so years, mostly in offensive security, but I've also had kind of weird jobs, I guess you'd say, as the first big data manager for companies like John Deere. I've been a principal red teamer at places like FireEye public companies, as well as principal software engineer at other public companies along the way. So my career has kind of been a mix. And a lot of the work you're going to see tonight is a result of a lot of hard work that Alex, myself, and team have done, but it kind of originated out of MITRE, where Alex and I met. And so we are kind of the beginning part of the MITRE Caldera framework, version 2 and up, I'd say. And so that's where Alex and I met. We went there in order to take over the research for Caldera, which is an automated purple team framework. And it really got popular within the government space and started to get picked up in the public space. And so that really, opened our eyes into solving some of the needs out there in the automated and manual security spaces and seeing what we could do. And that's really what you're going to see tonight. So we're really excited to show you guys. Alex, you want to give your background?
Sure. I'll go real quick. So my background is Air Force cyber warfare operations. I did offensive and defensive ops for the Air Force for a little bit. Kind of like David, had a background spread across various areas, did a little bit of public sector work over at AWS cloud security team. I've done some spooky things for reasons with a federal contractor. And then I also had obviously met David working at MITRE, where I was his R&D lead on the Caldera project. So I took a lot of like red team, the latest and greatest of what was going on with red teams, and I would figure out how we would automate that and integrate it into Caldera. And now I'm working with David at Prelude.
Perfect. Thanks, Alex. Yep. All right, let's dive right in. So the first part, what we're going to do is really introduce Operator as a tool, and the kind of primary purpose, really two purposes, I'd say, and we'll actually take it for a quick spin. And then Alex is going to take the reins after that and dive into some really cool integration points we have with open source project. Everyone's going to be already familiar with, but you're going to see some really cool things that we've done to kind of plug and play with existing work. So this is Operator. So when I pop it open, you're going to see an interface. So it's not just a terminal tool. The goal of Operator is to be a desktop application that you can pop open on Windows, Linux, and Mac equally. And so under the covers, it's going to be a Node.js application. I'll actually pop some source code open so we can dive through here as well in just a little bit. As a desktop application, the goal is to make it really accessible to get bootstrapped. So you don't have to run any dependencies or install any, in Caldera, a big hitch that we had was kind of dependencies you had to run as far as even pip requirements and that sort of thing just to get the server up and running. So as a desktop app, we're able to essentially compile those dependencies in and get you off and running with just the single app. So when you open it up, what you're going to essentially be confronted with is a command and control center. So at its heart, Operator is a C2, and it's broken into three components. You have the platform itself, which is what you see, desktop application. That's the kind of the core component. The other two components are agents and attacks. And so agents for us is, RAT to remote access Trojan. These are intended to run on remote machines, connect back to Operator. We have a variety of them written in different languages. Alex is going to take a quick tour on those when he gives his run through. Attacks for us come in the form of TTPs, which is a term that gets abused quite a bit. But for us, what that essentially means are single parts of an attack chain. So if I were to try to perform a lateral movement attack, I might break it down into three logical pieces. And each one of those pieces would be a TTP that I'm able to execute and perform a full attack. And we call that full attack a chain. So a little bit of terminology there that we have kind of adopted over time. All right, so looking at operator, I'm going to take us on kind of the primary case, which is to locate, modify, and execute a chain in a real test. And so the very first thing you're going to do is look for an agent that you can get installed. And so operator has the option of adding agents. It also comes with a pre-baked agent that's built into the app, really for test purposes, but you can kind of see it right here, accessible, ready to roll. There's an add agent button, so I'm actually going to start there and avoid the test one. And so we've got a variety of agents you can pick from. Our flagship agent is written in Golang, completely open source. You can find this on GitHub if you search for Numa and the word GitHub, because otherwise you might find tool songs. And so I do that. You can see a few other agents here as well. Most of our agents, I'd say, are multi-platform. So we've got variants, or we've compiled them so you can run them in different sorts of environments.
Detection-wise, these are kind of vanilla. There's nothing to try to hide the payload, I'm assuming.
Exactly, yeah. So Numa is the flagship, so this runs out of a binary. And so you can see the download script for this is going to drop it on disk and then execute it in the background. So this one will get caught by various file-based signatures. Other agents we have run only in as scripts, and some run in memory. So depending on kind of what you're trying to evade, that's essentially your decision of which agent you want to run.
We also provide some build scripts that will do like automated garble building of these if you want to compile them and get past that initial signature detection.
And these scripts are available in the product by default, right?
Yep, it's available on our open source GitHub repo.
Got it.
Yeah, we just try to make it easy so you can just copy and paste the download script and pop it into an, I'm doing it all local in this example to not have multiple computers, but you could pop this into any computer that you have that IP firewall access to. And so running it there just drops it in background. And so if I flip back to operator, I'm going to see a new agent pop up back here. And now I have that initial foothold. So I can do that as many times as I want. I can flip through these different agents. This one's written in Python. And I can repeat this, dropping the agents for whatever kind of case that I'm after. So every agent gives you a handful of options. I'm going to take us on kind of the primary one of launching chains. And you've got reverse shells built in. You've got, the profile, which is like configuration details for the agent. But I'm going to pop into launching a chain. So you can see here, you're going to be confronted with essentially what's the latest chain that the team has written. And I'm just going to hit the learn more so you can pop in and see what we're actually building quite a bit here on our internal security team. And so every week internally at Prelude, what we do is we build a new attack chain. We typically mimic some real life threat. Otherwise, we hit a category like ransomware or, really low level stuff. So you can through these, the change on this website to get a really solid idea. Here's the latest one released last week. Popping into the search, I can search for any TTP or attack chain that's been built. I can also start creating my own if I want. The one I pull out a lot for demos, just because it highlights a lot of, I think, interesting features, is File Hunter. This is a TTP chain that will run 4 TTPs, essentially trying to locate recently modified files on a system, move them around into a location to compress in a single spot, and then just sit there for exfiltration. So you can actually exfil this after the fact. Clicking on any of these TTPs in the chain is going to give you the underlying code. All the TTPs are classified under YAML format and then further classified by attack if you're into that to see the tactic and technique. Our primary focus on this, though, isn't the metadata, it is the commands. And so you can see here, every TTP is going to have n number of platforms that the TTP can run on. And then each platform will have n number of executors, or the things on the computer. It's essentially our term for the thing on the computer that can run the command. Could be shell, like in this case, you see bash and PowerShell. It could be pretty much up to your imagination and whatever you want to write. We've done some things that are in assembly. We've done some things in memory. There's some really cool executors that you can actually build. So once you go through this, you can attach more things. Like if I wanted to toss an ARP scan on this, just to get some interesting data, I'd search for one of those, toss it onto my essentially attack chain at this point. And I'll flip into the advanced area, which is where we can decide, do I want to run it against just the one agent that I was looking at? Do I want to deploy it against all my agents? Do I want to deploy this over an API? And then kind of the automated piece at this point. You can call a few of these pieces automated, I guess, but the true automation is if I want to drop this in and delay it to run at some point in the future. So you can push this out, a day, 2 days, however long you want to do that. And then deploying, it's going to toss out the agent. I didn't delay it, so I just told it to run now. You can see it running in the background. And so this allows me, I can lock it and unlock it if I want to kind of take manual control at that point. But this allows me to kind of quickly pivot through TTPs, attack chains, build things on the fly, toss them at agents and footholds that I have out in the environment, and really just take control of my security testing, I'd say, either automated or manual. As you see results pop in, click on them, you're going to get the kind of the context. What did we actually execute? We pull the information out of our own files. You can see the output as if you'd run this from the shell itself, and then anything indicators of compromise-wise that was parsed out. This is the automation I think that we're going to see a large direction of red teaming go, which is not full-fledged automation, but it is leveraging parsing systems that are able to parse out indicators of compromise and contextual information, which is what we aim to do in order to confront you essentially with this information. So you can look at this and say, okay, what do I want to do with that information now? So it kind of takes that manual parsing out of your hands as a manual red teamer and puts it into the automation so you can make those decisions yourself. So that's the basic kind of run through here. So I can flip this off, go back to this view. And that's my basic kind of bread and butter move. I want to show one more kind of key component here before I switch gears into the code, and that's connect. And so far what I've done is everything on my desktop. So desktop application, I'm running an agent, on my local network, and that's all great. But I can flip over to a section called connect, which allows me to deploy manual redirectors. So a manual redirector is essentially a headless version, not essentially, it is a headless version of Operator itself. And so you can go on our website, you can download these separately to Operator itself. And what this will do is you run this from the shell from any Linux server that you want. You do Mac as well. By running it on that remote server, you're able to then connect your desktop to that remote server. Wherever you put that, you can put it in AWS or GCP in Azure, and you essentially form a connection to it here automatically. And now you can send agents to your headless version of Operator that's linked back down to your desktop. So essentially adds a layer of obfuscation between your agents and your desktop. It's kind of like SOCAT, but it's like a prettier version of SOCAT that will allow you to stand up multiple versions of it and kind of connect between them. So it gives you a lot of flexibility from a red team infrastructure standpoint, that you can now accept agents over the internet into your desktop in a pretty secure way. And so the process here is really just download, run it, then toss in, it'll output you a host and token, toss it in here, and then you're automatically connected and you can run your operations that way. This also works really well at the team level, by the way. So your TTPs will sync across it. And so if you end up in an organization working in a team, we do have that option that you can set this up as a team server. So all of the things you do will kind of float between the redirector. All right, now I want to jump real quick into the code before I hand it off to Alex. So I'm going to show two things that actually not very many people have seen. I want you guys to have kind of a nice first glance at these two things. So the first thing I'll show is the Operator source code itself. And I think this is important because we're pretty big into transparency. I mean, Alex and I, from our backgrounds and really what we're trying to do mission-wise through Operator and the work we're doing with security and security teams is based around this. And so one of the things, actually, before I do that, if you go ahead and open DevTools on Operator itself, you'll notice we keep it enabled and we give you complete access to everything. So you can flip through all the logs, you can flip through all the source code, You'll find guides online for how to reverse engineer Electron apps. Pretty easy. We'll actually walk you through it too if you want to do that. So you can actually go through and check everything out. So where our attacks and our agents are fully open source, the platform itself is free and the code's accessible, but it's not open source yet. Because we're trying to make sure we can push something out that we can support. And that's the same sort of way we do agents and attacks. So until that time, we try to make sure everybody can actually view and access the code from this level.
Quick question for you. Regarding
Yeah.
encryption, you're encrypted between the agent and redirector, right? By default, if you use
Absolutely.
PS, I'm assuming.
Yep.
And are you also
Yeah.
encrypted between redirector and the application itself?
Absolutely. Yeah. So two different types of encryption are in play. Good question. Nobody actually asked that second one, and they should. The first one is agent to operator and agent to redirector. It'll follow the same kind of encryption, regardless how you set up agent to operator stuff. That is going to all run through AES encryption 256. And you can set an encryption key on both sides of the fence within your agent and on operator, and the encryption key needs to match for that connection to occur.
Makes sense. And other question
And then-
regarding the protocol itself, is it customizable by default, or you have to kind of stick with the protocol? Because I know, just spoiler alert, I know that you can actually write your own agent kind of thing if you worry about stealthiness, because we had that discussion in the past. But I'm just wondering, are you forced to actually follow the protocol structure that was designed by the application? I'm assuming that probably.
No.
No, you're actually not, which is pretty cool. So we offer 3 protocols built in right now, and it's going to grow. So TCP, HTTP, and UDP, you can swap the ports around here, obviously, and you can write agents or use our agents pointing at any of those. But we also offer a plugin system, and you can kind of learn how to write plugins as well. Here's an HTTPS listening post. So you can attach your own listening posts and your own protocols to operator through plugins. And so we've seen some people do some pretty creative stuff, even internally. Alex will talk about some of the stuff he's done with Sliver, which is pretty cool. But yeah, you can actually create your own protocols and attach them.
Nice, thanks.
And just to hit your point on the operator to redirector connection, that link, that runs through gRPC, and we encrypt that as well between the two. And just to highlight, this actually hasn't been published yet, so I'll give you guys the preview here. But this is a kind of quick view of like what operator desktop, how that connects to operator headless. And there's a connect service that runs within operator on both operator desktop and operator headless. That is a gRPC client server connection, and that's an encrypted tunnel. And so you can kind of see the link there. And I will hand it off to you, Alex, in just one sec, just so people can get eyes on source code, because it's always interesting, I think, to see the structure of an underlying project. So operator source code is structured, I'd say, pretty typically in an object-oriented type of way. So we've got a static directory, JavaScript, and then kind of a rules and responsibility for directories here. All of our connect-related features and linking happens within this area here. And so if you pop open DevTools, you can kind of find your way into the client and server. If you're interested in checking out both sides of that connection and you can actually look at the encryption used and get eyes on that. You can also see things like all the objects that exist within the ecosystem. These will tie directly to things that you would see using the application. And then from the user interface itself, all the code is segmented into each section as a different spot. One last thing I will leave you with as far as our development cycle is we care probably at an obsessive level about how many dependencies we take on as a project, where we do everything with the amount of dependencies. And so we try to track the project and the authors and the commits that happen in all of our dependencies, which naturally forces us to have less dependencies. And so there's a large effort there. That's another kind of big area for us on the development side. All right, Alex, I'm going to pass it over to you.
Great. I will
As you
take
pointed
over
out,
share
getting
screen.
that source code is fairly easy because it's an Electron app, so it's just a matter of unzipping a zip.
Exactly.
Exactly.
And if you don't know how to do it, we'll teach you how.
All right. Let me know if the text is legible over here.
Linking to you live. Yep, looks good to me.
Great. Okay. So I'm glad you actually asked that question. Are we able to extend protocols to do things beyond what was offered? And that's actually what I want to talk about. So one of the areas that we looked at when we were doing Caldera, but we never really got to dive into deep, is actually porting in a lot of the more modern techniques that are used. So one of the areas that I want to dive into is what we would call more quote unquote advanced executors look like inside of Operator. So what I'm going to do is actually walk through the process of adding in the Sliver plugin. So the actual system itself has just this base class that you can inherit a bunch of setup code that will allow you to extend and add pretty much whatever protocol you want. So what I have done is I've actually gone in and I wrote an extension to our base class that will actually wrap the Sliver gRPC protocol buffer and let you just natively connect in Sliver implants over MTLS. So that's what I'm going to do today, because what that lets us do is actually write basically implant agnostic TTPs that you can then run across, for example, Meterpreter's implementation of execute assembly and Sliver's implementation of execute assembly. And all you need to do is essentially write that interface between the agent and operator itself. So that's another one that I'm personally working on, which is Meterpreter. You can connect Meterpreter directly into operator and then have a Meterpreter implant, a Sliver implant, and some of our implants all running and send the same task and have it executed using whatever built-in native like execute assembly implementation they have. So let's take a look. So when we install Sliver, all you have to do is click this button. And the next thing we actually need to do is add the Sliver certificates. So I'm going to do that real quick. I have a directory set up. And what you can actually do is on your system, there will be a workspace folder, which we give you access to. And that workspace folder is going to have everything you need to dive into the data that we store on your system related to Operator. So in this case, we're going to portalprelude.org. And inside of here, you'll see all of the folders that we have, in addition to .secrets, which is where your unique encryption key per system is stored. So anytime you like install a payload or install a new TTP or add data, we're actually encrypting it with a unique key per platform, because we're like hyper aware of keeping data safe on your system. But what we're going to do is go into our plugins folder and go into the Sliver folder. And from here, we can just pop open this and we'll find all of the files related to the Sliver plugin itself. I'm actually going to show you the source code, but the source code is literally here. So you'd be able to just kind of grab it and dig through it if you're interested in it. For this example, I'm just going to move those certificates over so that I can show you how this works. So I just paste in those certificates and then go and refresh Operator. At this point, you're basically ready to connect in Sliver agents. And just like if you noticed before, when you add a new plugin, it just kind of like natively gets added over here as a new available port on your system. And this works the same locally on your desktop application as it would on your remote redirector. So I've added this MTLS beacon. I've got our encryption keys here. And all I'm going to do is now go over to a Windows machine where I've pre-staged that Sliver beacon and then connect it in. So you'll notice, like, this is our built-in agent, and you notice David earlier had run a NUMA agent. We kind of treat them all the same. We try to make Operator an interface between what the actual agent implementation is and what the implementation of a technique is. So let's take a look at some of the more advanced techniques. And when I say more advanced, what I'm referring to is essentially just like modern red teaming theory of using beacon object files operating inside your current thread, current process. So I pre-staged one called Sliver BOF and Execute Assembly. All of these are open source. So everything you see here is free and open source. You can go get the source code for it, and you'd be able to run this today if you go and you get the app. So inside of here, now that I've added the plugin, we have 4 TTPs that I've added. This first one is the register of the cough loader. So you'll notice if inside of this implementation, the difference here is we have the executor being register extension. What that essentially means is instead of calling like PowerShell like David did in his example, or Bash like he did in his example, the executor is just register extension. And this register extension is actually going to load the cough loader into the current process of the Sliver beacon. From there, you can then just call buffs the way you would normally. And what's neat about this, the way that we do this, is now you can kind of consolidate all of your implementations of a type of technique into one spot. So you could, obviously, if an agent has the ability to run like a command shell, right, you can run arp-a, but from an opset perspective, obviously you don't want to do that. So instead, you could use BOF, and I could just use this cough loader to load and run the ARP cough implementation that's available in Sliver. So we'll go ahead and do that. We also will do one for cackles as well. But something about cackles is there's a fact dependency, which I'm going to talk about in a moment. Lastly, we have execute assembly. So the same kind of thing, and what I was talking about being an interface between an agent and its implementation of a particular executor. So we would call BOF or execute assembly or shell or command. We call that an executor, essentially. It is the way that you will get code execution on a target. And here we have execute assembly. And the idea is that you'd be able to have your Sliver agents with an execute assembly implementation run this TTP, but you would also be able to task a interpreter beacon with its implementation of execute assembly with the same TTP, and use operator as that mapping interface between all of the agents that you have out in your environment. So it lets you kind of consolidate the red team frameworks that you have and make things a little bit easier to manage and consolidate the techniques that you're writing. So I'm just going to go ahead and lock that one was locked. So I'm going to lock that one. Locking just specifies order, and I'm going to click go. So you'll note it's going to go ahead and run. And the same way that the beacons respond, we get a response from the agent, and we can go through and we can take a look. So we can see that we actually did use the beacon object file for this ARP scan, and we can still, the same way we did with our shell commands, we can still parse out the indicators of compromise. And these indicators of compromise are what we call facts. And you're able to actually leverage these facts in future commands. And what that looks like is over here, we have this like special kind of pound squiggly bracket designator. And what that lets us do is jump into the configuration for this agent and add facts that will populate and render into those commands. So think of it as like if you're familiar with Jinja templating engine, it's the same kind of concept. You can template out commands, and then at runtime, as you discover information about the environment, you can then render out new commands and task an agent with them. So we actually saw there was a file.path, and we're going to pass it just like C users, Alexander Manners, and we'll do desktop and that. So as soon as I populate that in and save it, that fact is now available to the planning engine in the background, and we can actually send a task to the agent to execute. And when that happens, you'll note that template command had that pound file.path. It now gets rendered out with the fact that I gave to the agent, and we were actually able to run the list cackles for a user file. And the same way, we're then able to parse out indicators of compromise for what exists inside whatever command that we ran. So this one's grabbing a bunch of files, paths that we discovered on the target. And then lastly, just kind of a pretty vanilla like execute assembly implementation. This is just running like a pre-baked Rubius. This is using, I think it's the donut shellcode generator, I'm pretty sure. I forget offhand. I'd have to go double check. But the idea is essentially that you can pass in your assembly bytes and specify a process and then spawn a process and do some kind of process injection to run, to execute your assembly. So that, in a nutshell, is kind of the more advanced techniques being implemented and run through this automation technology. So I'll pause there before we dive into some of the agents and what some of the code for the agents and design patterns we use look like.
So, quick question. For example, execute assembly. Do we have the option to kind of perform the injection locally inside of a process? Because I'm assuming right now that your process parameters is probably where you want to spawn this. You know, one of the issue that we have with some of the tool sets in the market is the fact that they always force injection. But is it possible to actually run this inside of your own process?
It absolutely would be. So this implementation is just the implementation that exists inside Sliver. And Sliver uses process creation and injection into a remote process. If you wrote your own agent that lets you inject into the current process, or your own process, I should say, you could theoretically just pass, instead of process, you could just have execute assembly, or you could even literally just run this command and only pop off data.
Right.
Data is literally just a byte stream that gets passed to you. So you could run this TTP and just resolve data and inject that data locally.
Got it. Makes sense.
Cool. So I'm going to really quickly just jump through some of the code that we used. I think I'll jump through all of the agents that we have, and if there's any one that people are most interested in as I jump through them, we can pause and go more in depth on it. But I'll just give a high-level summary of the agents that we have, what they look like, where their primary use case is, and then we'll go from there. So where I will start, again, is with Numa. With Numa being our flagship. So, actually, I will start with Numa EX. So we have Numa and Numa EX. Numa EX is just an extension of Numa, so that's where we will start. We'll make sure that we post the link to this GitHub. This source code is all available for you. But this is a very basic agent that doesn't have a whole lot of complexity to it. It's a very good starting point if you're looking to dive into Golang to get an understanding of what a simple Go project would look like and how you could maybe write a little bit of a more fully fledged agent in pure Go without having too much complexity. Like Sliver is a very well-featured, well-built agent, but there's a lot of complexity in their source code that you have to understand to read through it. And we tried to make this an example of how you could have a pretty basic, but with that trade-off, easily detectable agent. So the source code, same kind of structure as a lot of our projects you'll notice as we go through. So main.go just lets you pass in the whatever command line arguments, and then all we end up doing is dropping into a very simple event loop. And if we go in and we take a look at the very simple event loop, the literal brain of this agent is just this function. There's not really a whole lot more to it. All it's doing is taking what exists as the passed in agent's configuration contact, which would be the endpoints specified in operator. So if you had TCP, HTTP, or UDP, all of which are supported by Numa, you would literally just specify TCP, HTTP, or UDP, and then we just call that implementation of communicate. So we're using like almost a factory function style design pattern here, but without a factory function, for lack of a better word. And then you'd be able to dive into these communicate functions if you wanted to see how everything actually works. One of the neat things about the way this is implemented is you're actually able to pass real-time configuration updates to your agent from the UI via here. So if you change like the AES key, or you change the sleep value, or you change the beacon target, for example, that will actually task the agent to update itself. And if you update the communication channel, the agent will actually swap its C2 channel from like HTTP to whatever you specified, if it's available. So if you had an HTTP agent and you pass in a configuration update of TCP with a new address to connect to, then it'll go ahead and actually swap you over to that new communication channel and start beaconing on that protocol. So this is NUMA. NUMA is really basic. There's no modular components of it. It's basically a monolithic binary. So our first kind of elevation of the out of the static single binary space is NUMA EX. And I have a blog post on this. It's the exact same project. So NUMA and NUMA EX code-wise are functionally identical. The only difference here is I have implemented a gRPC and RPC-based module system inside of the agent. And what I'm actually using is HashiCorp's project called Go plugin. And I will pull that up here. So the Go plugin system allows you to essentially specify a series of modules, and then you can dynamically request payloads and install those modules, and then communicate with them over RPC or gRPC. And there's different interfaces that you can dive into here that have the implementation for gRPC versus the implementation for RPC. But what that lets us do is back out some of the functionality that we might want to add, like Chisel, for example. If I wanted to install a Chisel SOX proxying function on that system, I can ingress this plugin and actually spawn a new process and start that Chisel proxy process. In that same vein, I can also spawn new processes to like do simple stuff like capabilities, dump LSAS, right? Just a very vanilla credential dump attempt. But the idea here is that you're trying to really like break the process chain that a blue team would be looking at. And right now, none of these are in memory loaded due to some limitations of both Golang and HashiCorp's Go plugin. But that's like an easy step beyond if you really wanted to like dive deep into Go source code. So those are our two kind of compiled binary agents. And next, I will jump into what we call our per-platform script-based agents. So we have three. We have Schism, Hush, and Jambi. And the first one I will talk about is Hush. So I wrote this one as a way to provide people who use macOS with a very simple script-based agent that they could use to bypass like macOS Gatekeeper. So you can actually run something on target without having to like get a signed binary and do all that kind of stuff. And actually, I think Octavia is on the call. Octavia wrote a very cool implementation of Doomfist's payload generator that lets you generate payloads with Hush. So Hush is like all of our other script-based agents. It is essentially just a script that all it does is it dynamically at runtime loads in some URL, the content of some URL, and then installs that as a function. There's not really anything else to it beyond that. So the logic of the agent itself is basically everything is a module. So when you want to like make a call out to your C2, it's the same methodology for making a call to execute a task, for example. So you retrieve your tasks by running your like beacon module, right? You just call run with beacon.contact as the name of the module that you want to run. And this would be HTTP, for example. And then once you actually get some links, and links are just like your incremental tasks that you want to execute, we pass it into this handle link function. And that handle link function will basically just call some more modules. So it'll say module.run. If there's a payload, run the request payload module. If there's a task, then run whichever module matches the executor you passed in. So for OS X, if we take a look, if you have an executor that has a bash, for example, a bash executor, it's just going to go dynamically load this and then call this module.bash function and return the data. Let's say you want to do like capture a screenshot of the system using built-in OS X functions, right? Same kind of concept. You would just have a TTP that has a screenshot executor. which I think I can pull up here. Grab screenshot via API. So you have this screenshot command here. So this global just means apply to all platforms, but it's instead of like PowerShell, right? It's going to be the screenshot executor. So the agent itself will see that it needs to run a screenshot executor. And then inside the module.run function, there's just some simple logic to install a module and then return basically the function callback that you would want to call in order to execute that particular module. So that is written in JavaScript for Automation, JXA, for macOS, and we apply that same pattern to one of our other agents, which is Schism. If we take a look at that one, Schism is a Python-based agent. If we take a look at that one. So I just recently refactored this one. And I think we're getting close on time, so I'll try to close out here in 3 minutes. So Schism is literally, if you were to look at the code, the pattern overall is very similar. There is essentially just an entry point where all we are doing is we are calling a bunch of modules essentially to achieve whatever our objective is. So the first module that gets called is literally just the same kind of contact. So module will be HTTP or HTTPS. You'll see the same kind of pattern. There's like a bash module, an HTTP module. And then we can run that module. That's going to resolve into links. And then we can drop into this run, and it's the same exact logic, right? Self.run or self._run, run the install module, and then pass it these parameters, and then actually call the module that is specified via the module name that's being passed in. If you were to go look at and compare the source code to the Hush source code, you'd see it's essentially very, very similar. I will quickly touch on another one. So the same kind of modular system applies to one other one that I wrote that is called Jambi. So Jambi gets after an area that I was interested in related to PowerShell that I call like micro functions to bypass AMSI. So you have like a bunch of ways to bypass AMSI, but a lot of them will like get signatured immediately. So what I wanted to do was build out essentially micro components into modules that you could load. And as of writing, this still runs like flawlessly without having to do anything in PowerShell. So the idea here is Jambi, like all of the others, are essentially just wrappers that all they do is they grab data from a URL and then they install it and they will call whatever function you've specified. So what we do here is we essentially have 3 separate functions that will let you build towards an AMSI patch, with the first one being an actual like creation of a load type. So you just create a load type and you return that load type to the agent itself. This actually gets returned as a fact. And what that means is that none of the other patch AMSI, patch ETW functions can get run until the patcher module has actually been installed on the system. So you're not like bringing malicious code until the actual patch type is created on the system. So we create the patch type, and then we're able to call like patch AMSI and patch ETW by passing in that new patcher type that got created in our first micro module, for lack of a better word. And by chaining these together, you can build more complicated and complex PowerShell kill chains that are much easier to bypass a lot of like AMSI and traditional PowerShell monitoring systems, or PowerShell blocking systems, I should say. So that's Jambi, and I'll just wrap it up there. We do have one other one that we haven't released yet that we're still working on, and that's largely been the work of Octavia, written in the NIM programming language, and that's going to be essentially a compiled down to C, fully modular, in-memory implant for multiple systems. So yeah, that's pretty much it. That was a lot, very fast, and I will pause there for questions.
Wonderful, thanks again. Maybe I want to go on something again. One of the cool thing about this is, as some of you know, red teaming is fun and creative, but there's also some part that are always going to be repeated, right? So with the whole TTP thing, you can kind of script all the boring stuff. Let's say, I don't know, for example, dumping Active Directory, getting all the users in the computer, or even run bloodhound route. And I think that this is actually really interesting because you could probably script like the first couple of commands and make sure that you don't even have to worry about it. Then you can move to a more custom approach. I was just wondering regarding the custom approach, is there a way to actually kind of type the command inside of the client through the UI, or you always have to have like this YAML file where you set up your things? Let's say you want to do execute assembly with something that you have on this. Is this possible for you, or you just have to kind of create?
So if you want to do that, let's say you wanted to do exactly that, you can just click create new TTP, and this is a fully interactive YAML editor. So you can just, if you want to like add your own BOF here, for example,
the YAML file. There's no possibility for you to kind of force a command by hand, right?
If you want, so some of the agents will have this interactive reverse shell, and this will actually spawn a PTY session and call back, and then you can like interact with the agent in a PTY session.
I'm more thinking, you know, for example, execute assembly, for example, you may not necessarily want to create a YAML file for every single command that you want to run, right? Because it may take forever, especially if you have some specific arguments for one of them. So I'm just wondering, how can you actually make that a thing using the framework?
Yep. So what I would do in that case is something like this. I would use, let's say I wanted to do a BOF, for example. I would specify, actually, you know what? Let me just go to the one that we already have, because that might make it easier to, oops. So if we were to go to here, what you could do, let's say you wanted to like specify the arguments you're going to pass in. You could just add something like,
I want it to be different. Like I want to be able to specify it. Is this possible?
Well, when you say arguments, are you saying like the arguments being passed into the assembly itself?
Both, actually. You know, just kind of make this command a bit modifiable, so you don't have to write one. So let's say, for example, here, whatever you're using, like in this case, Rubius. Let's say, for example, okay, cool. You're gonna script the curb roasting part of it, right? But what about, you know, if I want to use another feature, I don't want to necessarily always modify that YAML file.
Yeah, so what you could do, there's no way to like directly edit it before it's being run, but what you can do is use the fact language here, right? So this would create a Rubius.arg, like Rubius.args. You can name it whatever you want, and then all you would need to do is come into your profile and say like, for this run, I want my Rubius.args to be /repros whatever blah out file, and then that would save, and then you run it, and it's like, okay, well, now I want to run these arguments, and you can change the arguments here and run it again, and it'll just be the same like template. So what my recommendation would be, think in terms of templates. Like if you were writing this for, I want to render out a bunch of different commands to this HTML page for like my website or something, then you would want to specify it the same kind of way here. Like create a template that would work for you with whatever arguments you would want to pass in and however you want to handle those arguments. And then you can handle it inside your agent however you want.
Got it. I guess that was
the
pretty much it for me, question-wise.
The extreme version of that, Alec, if you wouldn't mind showing it, would be just like the entire command could be a variable, because really it's just a text swap of the variable at runtime. So you could actually say, hey, I want to pop it open, and the extreme example, like, the whole command is just a fact.
Yeah, you could literally like at the extreme end, you can just have this, and it's like command to run, and then whatever command you run is going to be specified in here with a command to run fact.
Right. That makes sense. Definitely. Anyone in the chat, any question for them? I guess I'll
If,
take this as a no.
If nobody has questions, if we have a couple minutes, maybe Alex, do you just want to like very, very quickly go over the protocol structure for beacons, like the beacon length, just so people can see what the JSON looks like, and you know that it's simple if you want to build your own.
Yeah, definitely. So one of the other things we provide is all of these docs are actually available here, but these docs are also available on our GitHub. So we'll link to our community GitHub. The same docs that live here live on our GitHub. And I think, David, we provide the link format here, right?
Yep, that third one. What is an agent?
Oh, link. What is an agent?
Yeah.
Here we go. So right here, we provide basically the data that you need in order to get a minimum viable agent connected into Operator. And this right here is the format of the tasks that will be sent to an agent. So as long as your agent is capable of handling data formatted like this, you can basically write whatever you want and connect it into Operator and handle the operations this way. And then we provide how to register your agent and how you would respond with the results of a task being executed. So after you get that initial JSON data that stores the links, you literally just respond on your beacon with the results of that links in a response, status, and PID. So pretty simple.
JSON-based protocol.
And this is like the base, bare minimum plain text protocol between operator and an agent. And then you can layer on kind of whatever complexity you want in terms of the network TCP UDP protocol that you actually want to implement. Something I've been looking at is how for Sliver we could do like WireGuard back to our redirector, for example. I'm also doing like Meterpreter's implementation of HTTP. So what does that look like? And then if you go inside the Sliver agent itself, so Sliver, all the Sliver plugin does is it's actually translating between this this protocol here, like this simple language here. It receives these instructions from operator, and then it translates these into a format that the Sliver agent can understand. That's essentially all it does.
Makes sense. And can you actually encrypt the payload and the requests inside of the packet by default, or if you remove the TLS layer, you can actually see all the command and payload in clear text?
Yeah, so by default, we actually have, so I don't know if you removed base 64, David, but by default, agents can beacon in either unencrypted with AES 256 or base 64. And then you can kind of like, if you write a plugin, for example, let's say you want to do like request wrapper or something, you could write a plugin that when your agent connects in, you could like replace this HTTPS plugin with your own implementation of HTTPS. Before the tasks are sent to your agent, you could do whatever kind of encryption you wanted to the request field, and then have your agent handle decrypting that request field, for example.
Makes sense. Got it.
Yep. 3 options will become, you can send an agent, you can send a beacon in 3 different ways by default, and we'll try to decrypt them with an operator. First one's plain text, like you see here. You could also base 64 it, and we'll attempt it. And then, like Alex said, the third one is encryption, which you can override with your own keys. Or if you want to get fancy, you could actually add your own encryption algorithm in as well, which we've had a couple cases for.
Got it. Yeah, that's the beauty of having the code be open source, right? You let people do whatever the hell they want because they're not forced to follow a model that was forced down their throat because it's closed source. So that's actually really neat.
Totally.
Any question based on what we just learned in the chat? Feel free to pick the mic if you just want to ask your question verbally. Of typing it. I guess you guys did a pretty good job at explaining the tools. Everybody figured it out, so they're going to be able to implement their own code tomorrow. So let's make a race, right? Whoever's going to come up with the first plugin win something.
We do have our own Discord, so if you have questions and you want to like follow up or whatever, definitely hit us up there. We can drop a link to it if you're okay with that, Charles.
Sure.
And
sure,
then
go ahead.
we'll drop a link to our Discord. And then if you have any questions, I'm on there literally all the time. So definitely feel free to reach out, and we're happy to help you in any way we can.
Yeah, just to actually add on to that idea, everyone, like Charles mentioned it, that a tool like this can be used for heavy lifting on a red team, right? Just to automate the boring stuff and get all that kind of not fun work out of the way. And like, as you think of these things, let us know, like whether that's in Discord or if you want to open an issue on our GitHub, because we're kind of constantly working with our community to build out either new TTPs or new functionality such as the Sliver integration. And so like, if there's a pain point in your workflow, if you see like an opportunity where this would work for you, come talk to us, and that might happen. So
Speaking of that, someone is asking the difference between Community, Pro, and Enterprise version.
David, do you want to riff on that? I'm actually typing up a response as well.
Oh yeah, totally. So we try to be pretty clear about them, so it becomes easy to understand, I'd say. So the application itself is the same across all the different licenses. So the app is the app. All the core functionality is going to be the same. The difference when you go up to a pro license, we try to make that as accessible as possible. And so you can see our pricing on the website. What you get with that is you get a subscription to the chains that our team internally builds. So we have a security team in here that Alex leads, and Octavia's on, and a handful of other security engineers from different backgrounds. And they build new attacks every Tuesday. We call it TTP Tuesday. And the pro license, you get a subscription to that. It loads into Operator automatically, and you can kind of take those TTPs and chains and run with them. The enterprise license is really infrastructure based. And let's say you wanted to set up a full-fledged red team infrastructure, set it and leave it and come back later. That's really what the enterprise level does. And so what we give you at that level is we give you the capability of turning your redirector into a team server. And then we give you something that we call Outpost, which is what I'd kind of call a cloud database, where you can store all of your own TTPs, all your chains. You can put them in a cloud database that syncs across your entire organization. And then you'll see the only place you'll see the word, I think, enterprise inside of Operator is in the connect section. And you'll see it's all infrastructure based. We allow you to kind of set up and manage your cloud infrastructure from within Operator itself.
Interesting. Thanks for sharing the difference.
Yeah.
And we also have the short version in the chat. So the professional version and enterprise pretty much allow other people to do the legwork for you. So every time there's something nice coming out, you actually write TTP for them, right?
Yeah. So we see I'd say the most common way we've seen enterprise run so far is on the red and purple side, when you're essentially tasking. A lot of us have probably been in these environments where you're on a smaller team and you're asked to essentially run security assessments for your entire organization. And so what we see is the setting up of this automation that can be run like hands-free while you go and you do manual work in one part of the org. You can kind of catch a low-hanging fruit in other parts of the organization by having your infrastructure kind of already set up and ready to roll.
Got it.
Yeah, you should. Another kind of resource to keep tabs on is the chains.prelude.org site that gets updated every week, and it's kind of fun, I think, to track the trends and the themes that the team here has our eye on, and are building out the different types of chains based on CTI that the team is aware of.
Yeah, I was about to ask, you have your private intel kind of thing as part of the company that feed you with the latest trend, or you just browse whatever it's publicly available and kind of make TTP?
Yeah, all of them OSINT right now, so publicly available information. Some of us come from Intel and places like, I used to work at FireEye, that sort of thing that come from more of the threat backgrounds. And so I think you're going to see some more action on that sort of thing in the not too distant future.
Interesting. I didn't know that you used to work at FireEye. When did you leave?
Yeah, so I left in 2018.
We probably worked together
yeah,
without even knowing.
What's that?
We probably worked together without even knowing.
Oh man, yeah, we probably did actually.
But I was on
Yeah,
the side, but yeah.
what team are you on?
The Canadian team from India, and so my boss, well, I guess my VP was Carmichael, but I don't
Yeah,
remember. He was a director, and he became VP at some point. But yeah, I was under Carmichael.
nice. I was under Jason Martin.
It
And
does
so if
ring
you're
a bell.
familiar,
It does ring a bell.
if you're familiar with the Nucleus project, not sure. That was my baby. If that's familiar.
I was on the red team time, so obviously I was just doing red team for Canadian company mostly.
Nice.
So didn't have much visibility, but I worked with Chris King, Evan Penna, and all those people in the state. Anyway,
Very cool.
Small world.
Yeah, definitely is.
So I guess if there's no other question, we're gonna call it a night. Hopefully you guys found this interesting. I generally believe that this is very interesting. And spoiler alert, one of the goals here is to actually at least dedicate one session on building our own implant that can actually work with the product. So that's on my to-do list, and I have a bit of learning to do myself. But that's one of the goals that we have on the channel, to actually write your own implant and kind of play with it. So if you guys are
Awesome.
interested, you're gonna get some templates to do so.
Well, thank you, Charles. Really appreciate it. And thank you, everybody, for listening to us today.
And we also learned something tonight, right? You can have Node.js interface that are pretty smooth.
Yeah. We hope so. We hope so.
Well, I really like the interface. It's actually straight to the point. No, no glitter, no magic. It's just like, you want this to be done, click here, and here it is.
Totally. It's definitely not Microsoft Teams.
Definitely. Anyway, so we'll call it a night. Thanks again, guys, and have a good one.
Okay, bye.